One very important industrial electrolysis that you need to sort of get comfortable with is electrolysis of alumina or aluminum oxide to produce pure aluminum. Now the process takes place in a setup like this. So this is a unit cell. The casing is made out of steel in order to be able to withstand such a rough environment. Then inside the steel we have a lining made out of carbon or graphite, which is connected to the negative pole of electricity, that's your cathode. And also we use another carbon rod or electrode as our anode, connected to the positive. Now this process does not go through just by pure alumina. And the question is why. The very first question you need to be able to answer is, why do we mix it with cryolite, which is a combination of sodium fluoride and aluminum fluoride, to carry the electrolysis through? The reason is because the melting point of alumina is greater than 2000 degrees Celsius, and it's not cost efficient. To have utilities to bring this temperature, it just simply doesn't pay, and what you produce is will be so much expensive. And you know, aluminum is extremely cheap. You go to drugstore and you buy the foil for a couple of dollars. When you mix it with cryolite, when you melt it in cryolite, the melting point gets reduced to 1000 degrees Celsius, which we can manage, and then we can do our process. Now, the oxidation reduction you should be able to follow. It's aluminum oxide molten. So first thing that you produce is free mobile ions. So you're going to have 2 aluminum, 3+, molten liquid phase, and you're also going to have 3 oxygen, 2- each, molten. Now aluminum we are interested, so let's see what happens to aluminum. It's going to go through reduction at cathode, 2 aluminum, 3+. I'm going to gain 6 electrons to give you 2 aluminum pure elemental form liquid. Since you're gaining, this is reduction, half. And then for, let's just do oxidation half for sake of completing this redox reaction. You have 3 oxygen, 2-. That is going to form into elemental oxygen or molecules of oxygen. So I'm going to have a 3½ O2 gas, and I'm going to lose 6 electrons in this fashion. Since you're losing electron, that's oxidation half. So this is aluminum we are interested in. Aluminum is going to take place at cathode. So aluminum is going to sort of get attracted to the walls. And what happens is aluminum, it has pure aluminum has higher density than cryolite, and it's going to come down here, and it's going to get drained here, and you have your barrel, and you're going to collect aluminum. Now what happens at your anode? You're going to produce bubbles of oxygen. So oxygen comes out, and here you have gases being produced. So these are oxygen gases. So electrolysis of alumina to produce aluminum is extremely important. The first question you need to be able to answer is, why do we use cryolite in order to reduce the melting point from 2000 to 1000 degrees Celsius? This process is extremely costly still. So just remember, recycling aluminum is much cheaper and it requires less energy. So aluminum cans can be recycled rather than we give you aluminum from scratch.